So picking up where we left off last time, we're looking at the conversion of fractions to decimals. How are they related? And as we were converting fractions to decimals, we found one of two things happened. Either the conversion ended up with a decimal that terminated, or it was a repeating decimal. And when we talk about repeating decimals, what we mean is there's a chunk, a fixed chunk that exactly repeats over and over again. So there's this fixed set of digits that repeats. So example of a terminating decimal would be, for example, 1/4 we know equals 0.25. We can do long division or plug it into a calculator and we say, hey, it just stops right there. And then there's repeating decimals like, say, 1/3, which is 0.333, and those threes keep going on forever. And we usually put a bar over the repeating part. Another example we saw the other day was 1/6. 0.1666, and there my intention is that only the 6 repeats, and sometimes bigger chunks repeat. For example, 3/11 is 0.27 repeating, oops, 27 repeating, and the 2 and the 7 repeat. And 1/7 is 0.142857, and all 6 of those digits repeat over and over again. Cool thing about sevenths is 2/7, you may have seen this in your spreadsheet, is the same set of digits, but they start in a different place. It starts with the 2, 8, 5, 7, and then picks up the 1, 4, which is kind of neat. Then there are things that kind of repeat, but not like this. So this is a different category that we'll talk more about later, but consider the decimal 0.1001000100001. Do you see the pattern I'm getting at here? I can't draw a bar over anything here because the number of zeros between the ones increases by 1 each time. Okay, so this is not a repeating decimal in the sense that the ones above are. And I'll come back to this at the end of the chapter. But what I'm trying to make clear here is, what does it mean to say we have a repeating decimal? It means a fixed set of digits is repeating. A single digit repeats here and here, 2 digits repeat here, 6 digits repeat here and here, and it's the same set, same size, same order, over and over and over. So I can make a rubber stamp of the repeat. Can't make a rubber stamp here that's going to work the same way again and again, right? A single rubber stamp doesn't work here. So this is some other decimal animal, different from this and this. It's a whole different class of number. All right, off to our spreadsheet. And so I'm just going to kind of repeat what I did last time with the spreadsheet and hope you notice something different. And I'm going to put you guys in groups to discuss this. So let's see, I need my Google Drive. And there's my fraction sheet here. It isn't, so I got to find it. So maybe fractions to decimals, cool. Put it in the right spot. All right, so here's my spreadsheet. I'm gonna make a copy of it and kind of start over. So I'm just gonna delete my calculations. So the goal here was I wanted to have the denominators 2 through 32. There's my denominators. And then some numerators. I don't need 1 through 32 for numerators. What did I go up to here? I went up to 10. That's fine. If you wanted to go farther for numerators, that's cool. You can. But for sure, we needed those denominators. And then what I want to do here is I want to say, okay, given this numerator divided by this denominator, what's the decimal look like? And then down here, basically, I want that same numerator, but the new denominator. Oops. Same numerator up there divided by this new denominator. And suppose I want to fill up this column with fractions. Whenever you fill a formula down, it's going to, or right or left, it's going to want to change the row number or row reference. That's called relative cell referencing. So this formula right here says, grab the number above, divide by the number to the right. Now, although I always want to divide by the number to the right, I don't always want the number one cell above. I want the number in row 2 up here, right? So what I'm going to do is I'm going to fix this formula to say, although I want you to grab the new denominator, as far as the numerator goes, I want you to always grab row 2 there. And so then I can take that and fill it down. And so I should get 1/3, and then 1/4, and 1/5. So I can grab that single formula if I typed it right and fill it all the way down. Now, if I don't put that $sign in there, things go to hell. And I just want to make sure things look right. 1/10 is 0.1, right? Now, if I do this wrong, delete this and do it wrong just to demonstrate proper spreadsheet usage. If I just think that the formula that says grab this number and divide by that number, if I think that's always going to work in this column, I can just try it by filling it down. And what I should see is I get some weird stuff. Oh. In some cases, I get 0. 1/10 should be 0.1 in slang. That ain't 0.1 right there. So I can see I totally screwed up. This formula, again, says, although it looks like B2 over A3, it says grab the number 1 cell above, divide by the number 1 cell to the left. And it just repeated that. Down here, it says, hey, grab the cell above, 1 above, and divide by the 1 to the left. So each time I get the correct denominator, but the wrong numerator. So that's why in the original formula, I realized that it's changing this 2 here to a 3, right? And then to a 4. So it's always messing up the numerator. So I tell it, okay, wait a minute. Don't mess with the 2. Always use the 2, $sign, and then fill it down. What's different this time compared to last time I did this? Anybody? Somebody comments.
Where you put the $sign at?
Yeah, I put the $sign in a different spot because last time I generated rows instead of columns. So here's the question. Now I could keep doing the same thing. Say, okay, grab the number above and divide by this number way over there. And don't forget to always only grab that one right there. And then Google says, hey, you want to fill it down? I could say, sure, why not? Okay, so it did that, right? There's 2/10, that's correct. I could do it 1 row at a time. When I did it the other way over here, I did it a little different. I went row-wise. So I said, okay, grab this here and divide by that there, but I want to fill it to the right. And if I just try to do that without messing with it, don't fill, please. So I want to fill it row-wise here. It's messing stuff up, right? 2/5 is definitely not 10, and 3/5 is definitely not 0.3. So something went wrong. And if I look here, I can see, okay, grab the right numerator, and there's my denominator. But over here, grab the right numerator, but the wrong denominator, right? It changed the B, or let's see, the A for where the denominators live here, column A. Over here, it changed it to a B. Over here, it changed it to a C. So what happens is when you copy a formula or fill it in a direction, if you move it left or right, it changes the row or the column letters. If you move it up and down, it changes the row numbers. So in order to fix this, I have to say, okay, don't mess with column A because that's where the denominators live. $sign A, but I do want a new numerator every time I go to the right. So I have one technique that gives me rows, I have another technique that gives me columns. Wouldn't it be nice if I could do them both together? And I was hoping somebody would email me and say, hey, let's mix those two together in one shot. Shall we try? Or is everybody good enough with their spreadsheet?
We should try it.
Okay, thanks, Bianca. I love your sense of adventure. All right, so I'm gonna do a new spreadsheet where I try to mix those two techniques together. So I'm just gonna copy all of this one, maybe, out of my way, toolbar. Copy, paste, delete the middle stuff. All right. So what I'd like to do is write a formula that I can copy right and copy down and have it not mix stuff up. All right, so here's how it goes. First one is pretty straightforward. We just say, okay, numerators come from here, denominators come from there. Now, the denominators always live in column A, true? So I just have to tell the computer, $A, always look in $ in column A, right? That's what the $ says. Don't touch the A. You can change the 3, but don't touch the A. Where do numerators live? They always live where?
In row 1?
Not row 1, almost.
Row, no, 2, sorry.
2. They always live in row 2. So for the numerators,
I was reading the wrong line.
Yeah, for the numerators, I just say, hey, don't mess with the 2. So this puts both those strategies together. So I hit enter, and then it wants to fill down. Sure, why not? And then what I can do is I can highlight that whole column of formulas and fill it to the right as far as I want. So maybe I'll go over here to column J. And let's just confirm that it did it right. The tenths is a good place to look. And notice my tenths all look correct. So that looks pretty good there. So I think I got it right. What's another place that's easy to check? The 20ths. 20ths should be nice. They're half of the tenths. Right? Half of 0.3 is 0.15. Half of 0.6 is 0.3. Yeah, so those look good. So I'll repeat that again just for fun. Here I want a formula that repeats in 2 different directions, which means I need $ in 2 spots. If you put too many $, it doesn't work. So I have to put just enough. So my first one is say, hey, grab the numerator above, divide by the denominators to the left. And then I realize that if I just tried to fill this as it is, crazy stuff's gonna happen. Okay, so that's all broken. That's a mess. That is not what those fractions should look like as decimals. So I messed up and I realized, oh, it needs to know that the numerators are only in row 2 and the denominators are only in column A. So we have to fix those like that. And then from there, you can fill it any direction. Oops, went a little too far. Let's get rid of that stuff. And then I can look back to see if easy stuff looks good. Do my tenths look right? Yep. Do my 20ths look right? Yep. Okay. So that is the spreadsheet that we're going to try and use to answer the question, when does a fraction lead to a terminating decimal, and when does a fraction lead to a repeating decimal? There are some patterns living in here. And so this is my turn to shut up and put you guys in groups to figure it out. Okay, so we got some questions to clarify. So again, we're trying to figure out when will a fraction terminate or repeat. So if I just throw a number out there like 3/25, without doing division, 25ths, will that repeat or terminate? Anybody? Without doing any division.
I feel like it would repeat.
Okay, so we have a repeat maybe? Okay, so we have a whole bunch of evidence in the spreadsheet. So where's that spreadsheet? So you need to have your spreadsheets out. And for example, halves, they don't seem to ever repeat, right? In this row. Thirds seem to repeat most of the time, except for like 3/3 and 6/3, where it's not really a fraction anymore. fourths and fifths, do fourths ever repeat or do they always terminate?
They always terminate.
Always terminate. Fifths, always terminate, always repeat,
Terminate.
terminate. Sixths, mostly repeat. Sevenths, mostly repeat. Okay, so you're trying to look at this pattern of when things repeat and when things terminate and see if you can say, oh, all the ones that terminate have this in common, and all the ones that repeat have this in common. What are those things they have in common? All right, back to your rooms. Talk about it some more. Puzzle this out.